What are Solidity libraries and why do we need them? Let's understand it with an example. For example, you can create a library contract with the keyword library and then the library name, let's say ArrayLib. So inside the ArrayLib, I can create all the functions that are related to array. So I can manipulate the data. For example, I can reverse the array, I can insert something, or I can find the index. So by default, this functionality is not available natively in Solidity. So you can create a library and you can deploy it on the blockchain, and then anybody can use that library by just using the library address. They can integrate the library in their contract, and then they can start using the functions that you have made available inside the library. So that's the reason library can help you save some gas instead of writing your own methods every time, which is time consuming. And this is really good for the code reusability. Now let's create a function here. Let's say reverse. And I can take input in this function. So let's say uint storage, and let's say array. Set it to external view, and it returns, let's say, uint memory. Now here let's create another memory array. Let's name it reverse array, and you can do new uint. Since we cannot create the dynamic array in functions, so we have to give the length beforehand. So do length of the array that we are passing, and now we have created the fixed length array here. So let's correct the spelling. Memory, okay, underscore array. Cool. So now let's do uint count equals to 1. Create a for loop. Uint I less than underscore array dot length and I plus plus. And here we can do reverse array. Do array length dot length minus count equals to array and the index of the element that we are reading, and then do count plus plus. And now here let's do return reverse array. Now let's create a contract where we can use this library. So contract, let's say code is alert. So in this contract, I want to use the library. So first we need to create the array here that we want to pass and manipulate. So let's say 1, 2, 3, and 4. And let's create a function here. Get reverse public view returns uint memory. And here I can do return name of the library, which is ArrayLib, and then dot the function or the method that we want to access, which is reverse here. So do reverse and then pass the array. And that's it. That's how you can access the methods from the library. So let's deploy this contract. Make sure you select code is alert. So when you select the code is alert, behind the scene, Remix is going to deploy the library first, and then it is going to link this library with your contract address. So at the back end, we will have two different addresses, first for the library and second one for the contract, and that will be linked to your contract here. So deploy it. Now let's get the reverse. And as you can see, it is giving us 4321. There are a couple of things about library. First, you cannot store any state variables inside it. If you try to do something like string public name, it won't allow you. The only variable that you can store inside the library is constant. So you can do, let's say, uint const, and let's say number equals to 10. So this will work because you are not changing anything. It is a fixed number. It is constant. So the constant values you can store inside the library, but you cannot store any other data inside it. And one more thing, when you pass the state variables to the other contracts, we use the keyword storage. So most of the time you might have seen memory. So this is the reason that we are using storage, because we are passing the state variable to the other contracts function. So that's the only way you can pass it. And you can change the data inside the library, but that data change will be in the context of the calling function. So let's understand that with an example. For example, I have one more function. Let's say function insert. I know you can directly insert the data inside the contract itself, but this is just to help you understand. So let's go with the uint again. We will pass the same array and storage, since we are passing the storage variable, and set it to public. We don't want to return anything. Underscore array dot push and underscore number that will pass in the array. So receive one more argument here. Let's say uint num, and that's it. Now inside this contract, let's copy the whole function, and here we can do insert number, and let's receive the number from here, uint underscore num, and remove all of this. And here we can do insert, and array is okay. And then here we can pass num, and that's pretty much. So now let's deploy it again. First call this function. We got the reverse of the array 4321. Now if I'll insert the number, let's say 5. So now it should insert. So this insert has happened in context of this contract. So the 5 was added in this array, not in library's address. Library is just a temporary storage or just the data manipulation, but the final data will be stored in the contract that is calling it. So now if I'll call the get reverse, you will see 54321. So why are we getting 54321? Because the final data was added in this array here, not in library anywhere. Library itself cannot store the state variables. So it will be always in the context of the calling function. There is one more way to access the library methods inside the contract. You can use using, then the library name, which is ArrayLib in our case, for. And since all the methods are associated or are related to the array, so you can do uint. So what this will do is it will make all the methods related to array available inside this contract. Now you can do array and you can remove it. This is more readable. So also here, let's remove it and just pass the num. And that's pretty much. So now let's deploy this contract, and this will work the same way. See, we are still getting the results. So this is a better way to use the libraries, by using the using keyword, because this is more readable. In the next video, we will see how to use the library that has already been deployed by someone on the blockchain.